Solve the polynomial inequality and graph the solution set on a real number line. So we have already factored equation x minus 4 times x plus 9 greater than 0. So we know already the boundary points. So we can solve each of these factors. So x minus 4 equal to 0 and x plus 9 equals to 0. So the first equation gives us x equal to 4 and the second x equal to negative 9. We plot these points on the real number line, negative 9 and 4. These are the boundary point. This expression, this function, change the sign or can change the sign only at the boundary point, nowhere else. So also we have the sign greater than 0, not equal to 0. It means that the point must be cut off from the solution set. They are not included to the solution set. So now we have to determine which sign has this function in each of the intervals. The boundary point divided the real number line into 3 intervals. So we can pick up one value from each interval and to determine the sign. For example, in the middle, we can take 0, substitute 0 in our function expression. So 0 minus 4 times 0 plus 9. Minus 4 times 9 is less than 0. So in the middle, we have negative sign. On the left, let us pick up x equal to negative 10 and substitute in the function equation. Negative 10 minus 4 times negative 10 plus 9. So negative 14 times negative 1, positive. Positive means that to the left from negative 9 we have positive values of the function. And the third interval, let us pick up x equal to 5 and substitute into the function equation. So 5 minus 4 times 5 plus 9, it will be 1 times 13 greater than 0. So to the right from 4 we also have plus. So the question is where f of x, our function, is greater than 0. It is greater than 0 to the left from negative 9 and to the right from 4. So the solution set in the interval notation will be given by these two intervals from negative infinity to negative 9. Negative 9 is not included, so we use parentheses. And the second interval from 4 to positive infinity. For infinity, we always use parentheses. Because infinity is not reachable, we cannot use square brackets there. We cannot include infinity into the interval. So the next equation, inequality. So let us do it very quickly. X minus 6 times x plus 1. So the first boundary point, the 0 of the first factor is x equal to 6. The 0 of the second factor is x equal negative 1. Negative 1 and 6. We have less than or equal to 0. So that's why we will include the points into the interval, because the values of x where the function is equal to 0 are also included in the solution set. Then we must pick up the points from each of these 3 intervals. Let us start from the left, x equal to negative 2. Substitute it in the equation, negative 2 minus 6, negative 8, negative 2 plus 1, negative 1. Negative times negative will be positive. We have plus here. In the middle, let us take 0 in the middle between negative 1 and 6. Will be 0 minus 6, 0 plus 1. Negative 6 times 1, negative. So we have negative in the middle, and let us pick up the number greater than 6. Let us take 7. 7 minus 6 will be 1. 7 plus 1 will be 8. Is positive. So we have plus. So the question was where this function is less or equal than 0, and it is in the middle. In the middle, including the boundary point. So on the interval from -1 to 6, including -1 and 6, that's why we use square brackets. In this case, the equation is not factored. X squared minus 15x plus 54. We have to factor this equation first. So we can use trial and error method by finding two numbers that have the product equal to 54 and the sum equal to 15. So maybe they are 7 and 8. They must have the same sign because the product is positive, but they add up to negative 15, so both must be negative. X minus 7 times x minus 8 greater than 0. This is our inequality. So we have two boundary points. The zero of the first factor is x equals 7. The 0 of the second factor is x equals 8. So 7 and 8. The zeros should be excluded from the solution set because we have greater than but not equal sign. To work more quickly with the quadratic function, you know of course the graph of the quadratic function. It is the parabola. If the coefficient by x squared is positive, the graph of this equation will be parabola opened upward. Yes. So you have found two zeros of this parabola. So it crosses the x-axis at this point and goes up. So if it is a quadratic function, it has a parabola as a graph. Its graph is a parabola. If the leading coefficient positive, the parabola is open upward, and you definitely know that it is negative between the points and positive to the left and to the right. So here it is positive, negative, positive. The question is where this function is positive. So we have these two intervals from negative infinity to 7 and from 8 to infinity. Of course, we have parentheses everywhere because we have greater than but not equal sign. And the rational function, rational inequality. So here we also see the boundary point at once. So the boundary points are the zeros of the numerator, x minus 2 equal to 0, and the zeros of denominator, x minus 1 equal to 0. So if you solve this, then x equal to 2 and x equal to 1. We have two boundary points, 1 and 2. So the function will be able to change the sign. Important thing here is that the function is not defined at the 0 of the denominator. So it means this is the 0 in denominator, and the function is not defined at x equal to 1. So the 1 must be excluded from the solution set. So although we have here the sign less or equal than 0, we cannot include 1 in the solution set. So now we have to choose the correct interval. Let us pick up values from each of the intervals. From the first, let us take 0, it is less than 1, x equal to 0, and substitute in the function 0 minus 2 divided by 0 minus 1. Negative over negative will be positive. So it is positive to the left from 1. From the second interval, let us take 1.5. 1.5 minus 2 will be negative 0.5. 1.5 minus 1 will be positive 0.5, so negative over positive will be negative. So it is negative in the middle. And the last interval, let us take 3. It is greater than 2. X equals 3. And substitute 3 in the function equation. 3 minus 2 will be 1. And 3 minus 1 will be 2. So the function is positive to the right from 2. So the question is where it is less or equal to 0. So it is definitely the middle interval. 1 is not included and 2 is included in the solution set. So we use parenthesis on the left, the interval from 1, and square bracket to the right. From 1 to 2, 1 is not included, 2 is included into the solution set.